Okay, section 5.4 talks about the other trigonometric functions. And I want to give you the functions, and then we'll talk about what they mean. So tangent, secant, cosecant, and cotangent. So let's think about our point on our circle. And what do we know? Well, we know that x over r equals cosine theta, and y over r equals sine theta. And so tangent, the tangent function is equal to y over x, which if we do a little bit of work with algebra, we can see that that means the tangent is also equal to the sine of theta divided by cosine theta. Secant is the radius divided by the x-coordinate, which means that secant theta is 1 over cosine. And that one's easy to get confused. You just kind of have to memorize it. Cosecant is r over y, which means that cosecant is 1 over sine theta. And cotangent theta is x over y, which means that cotangent is cosine theta over sine theta. And whoops, sorry, there should always be a theta. There should always be an angle upon which your trigonometric function operates. Cotangent theta is also equal to 1 over tangent theta. Okay, these are identities. These four functions give us a relationship between different trigonometric functions. They relate tangent, secant, cosecant, and cotangent to sine and cosine and to one another. And these are the definitions of tangent, secant, cosecant, and cotangent, and they're all based on rotation around a circle of radius r and the coordinates of that point on the circle. And so we can do some of the same sorts of things that we have done before. So let's start with an example here. Let's evaluate the tangent of 45 degrees. What do we know about 45 degrees? Well, we know that the sine of 45 degrees is equal to square root 2 over 2, and that the cosine of 45 degrees is equal to square root 2 over 2. We also know that the tangent of 45 degrees is equal to sine of 45 degrees divided by cosine of 45 degrees, which means that the tangent of 45 degrees is equal to root 2 over 2 divided by root 2 over 2, which equals 1. Okay? Let's try another one. Let's try the secant of 5 pi over 6. Okay, so the first thing we have to do is figure out where we are on our unit circle. So let's sketch our unit circle. We know that 5 pi over 6 is one of our special known unit circle values. And it is this one right here. It's this guy. Wrong. It's this guy. So this guy has got coordinates. So based on my position in the unit circle and what I remember about my unit circle, I know that the sine is 1/2, and the cosine of 5 pi over 6 is negative root 3 over 2. And if you want to check yourself, you can go to the book on page 328 and look at your unit circle. And we see, let me pull this in. So let's just check my memory here. All right, so let's look. Sure enough, 5 pi over 6 is where I said it was. It's x. The x-coordinate of that point is negative root 3 over 2, and the x-coordinate is related to the cosine of the angle, so that's correct. And the y-coordinate on the unit circle is the sine, so perfect. Okay, so what good does that do me? Well, remember that secant of 5 pi over 6 is equal to 1 over cosine which is 1 over negative root 3 over 2, which is negative 2 over square root 3. And I will take that, as I believe will my open math. If it bothers you to have a radical on the bottom, you can also give me negative 2 square root 3 over 6, which would be, over 3. Okay. All right. I'm going to stop this video here, and we are going to talk about simplifying trigonometric expressions in the next video.